Good morning, maybe good afternoon to some of you. We are beginning Chapter 4. We had our Chapter 3 assessment last week. Now we're starting Chapter 4. We're going to begin on Lesson 2, page 265. We're beginning with multiplying fractions and whole numbers and multiplying fractions and fractions. They're very similar, okay? So we're going to cover both lessons in one video. To start, we're going to talk about the commutative property. Okay, the commutative property just states that you can multiply any numbers in any order and get the same answer. However, you cannot divide any numbers in different orders and get the same answer. For example, you cannot take 12 divided by 6 and get the same answer as you would if you took 6 divided by 12. Okay, 12 divided by 6 is going to give you 2, exactly. Okay, and then if you take 6 divided by 12, you're going to end up with a decimal. It's actually 0.5 because 6 is half of 12. Okay, so you cannot switch around a division problem. You have to leave it exactly as is. However, you can switch around a multiplication problem. The commutative property states that 5 times 7 and 7 times 5 are going to give you the same exact answer of 35. This holds true for another operation. Which operation can you switch around and get the same answers? Addition. Exactly. Okay. However, you cannot switch around subtraction. Okay. That would not be commutative. So commutative says tying your left shoe and tying your right shoe, it's the same exact thing. You're going to do it exactly the same way. Okay? And it also states that you can add two numbers in different orders and still get the same answer. If we added 15 plus 5, we're still going to get 20, just as if we would take 5 plus 15. Okay? Turn the page. So now we're on page 266. Okay, and we're talking about multiplying a whole number by a fraction. This is one of the toughest things and the main thing you have to remember when multiplying whole numbers, okay? A whole number is just a number all by itself, okay? And then this is the fraction, okay? When multiplying whole numbers, you must put it over 1, okay? You write the whole number as a fraction. To do that, it's the same as putting it over 1. If you took 5 and divided it by 1, you're going to get 5 wholes. Okay? So whole numbers are always over 1. Remember that. Whole numbers always put over 1. Okay? Drill that in your head, highlight it, write it really, really big. Do anything you can to remember that whole numbers always go over 1. Okay? And then it's simple from there. You multiply straight across. Here we multiplied 5 times 3, and we get 15. 4 times 1, and we get 4. So we get 15 over 4, which is also known as an improper fraction. When your numerator is bigger than your denominator, it's an improper fraction, and you have to divide to get the answer. So if we divided 15 by 4, we'll see what we get. 4 can go into 15 3 times. Now, I know we've been doing decimals and we've been doing remainders. Now we are working on fractions, okay? So if I divide this out, 5 minus 2, I'm going to have 3 left over, okay? We're done with decimals. We're not working on decimals right now. We're working on fractions. And we're not working with remainders, okay? So remember this. Whatever your remainder is becomes your numerator, okay? And then whatever you're dividing by becomes your denominator. So our answer would end up being 3 3/4. Okay, let's do some practice ones. Just kidding. I'm on the next page, page 267, okay? we're going to multiply a fraction by a whole number. It's the same thing as multiplying a whole number by a fraction. Exactly the same thing. The order does not change the product. Okay, so I can take 4 times 3/5 and 3/5 times 4 and get exactly the same answer. Again, this is the commutative property. So if we take 4 times 3/5, go ahead and do that. Okay, start it out. First thing we're going to do is take our whole number and put it over what? 1, exactly. And then we're just going to multiply straight across. 4 times 3 gives me 12. 1 times 5 gives me 5. Now my numerator is bigger than my denominator, so I have to divide them. I can never leave it as an improper fraction. So if I take 12 divided by 5, 5 can go into 12 twice, and I get 10 with 2 left over. This becomes my numerator, so I have 2 over 5 becomes my denominator. This is my numerator, this is my denominator. Okay, vocab. These are all vocab words, right? So our answer would be 2 2/5. If we switched these around, we're going to get exactly the same answer. Okay? We're going to go down to example number 3. Okay? Here they took 1/4 times 5. First thing they did, they put 5 over 1. Okay? And then they're going to multiply straight across, and they get 5/4. That is an improper fraction. They had to divide that out. 5 divided by 4. 4 goes in there once, with 1 remaining. This becomes my numerator. Okay? 4 becomes my denominator. And that's how they got the answer of 1 1/4. Okay? This is called renaming an improper fraction. Okay, right here. Renaming an improper fraction. You divide the numerator by the denominator and write it, the remainder as a fraction. Go ahead and do D, E, and F. Pause the video, do D, E, and F, come back, and I will show you my problems worked out. Welcome back. Here you'll find my answers and my work for D, E, and F. Letter D, I got 1 1/2. Letter E, I got 1 3/5. And letter F, I got 3 3/4. Look at the work. If you didn't get the same answers, look and see what you did. Write down any questions you have, and you're going to bring those to your groups this week. Okay? Turning the page all the way to page 274. Page 274. Okay? This begins lesson 3. Multiplying fractions times fractions. Here we're going to learn a lot more about simplifying in your problem. Okay? Multiplying fractions times fractions is exactly what we just got done doing. We multiply straight across. If the problem says 2/5 times 1/2, all we're going to do is multiply straight across. We're going to do nothing more but multiply. So now we have 2 over 10. Those are both even numbers, so I know that they can be simplified. Any number that ends in a 2, 4, 6, 8, or 0, I know for a fact that 2 can go into those numbers and they can be simplified. So if both numbers end in these digits, it can be simplified. Okay? Other digits make it a little bit more difficult, but that's why you have your factor T charts. You should be looking at your factor T's. If you look at your factor T's of 2 and 10, factors of 2 is 1 and 2. Factors of 10, 1, 10, 2, 5. The biggest number that they have in common is 2. Okay, so that's saying we're going to divide each number, the numerator and the denominator, by 2. And our answers are literally on our factor T charts, right here. Our 2 is going to change to a 1. Our 10 is going to change to a 5. They were right there in front of us the entire time. So I told you that it was important to do your factor T's. Okay, so our answer would be 1/5. because 2 divided by 2 is 1. 2 goes into 2 one time. 10 divided by 2 is 5. 2 goes into 10 5 times. 2, 4, 6, 8, 10. Okay? Let's try some got it problems. Go ahead and do A, B, and C. Pause the video, come back, see my work, compare your answers, figure out any questions that you have. Welcome back. Here you'll see my work. I also worked out my factor t's so that I knew exactly what I was working with and how to simplify the problem. Okay, so for letter A, I got 3/10. Could not be simplified. They had nothing in common when I worked out the factor t's, so that was as low as it could go. Letter B, I got 1/4. Okay, it was 3/12. When I worked out my factor t's, I saw that they both had the number 3 in common. So then if I divide each of them by 3, I end up with 1/4. Letter C, I got 5/9. Okay, I started out with 10 over 18, but when I worked out the factor t's, I noticed that they had 2 in common. Okay, so I divided each of them by 2, and I ended up with 5/9. All right, next page. Simplifying before multiplying. This will make your life so much easier. Do this, okay? When you simplify in the problem, you're working with small numbers instead of big numbers, okay? So to simplify within the problem, you're finding the numerators and the denominators across from each other, which factors they have in common. So if we're looking at this problem, we're looking at these two numbers. What factors do they have in common? If we work out the factor t's, we have 2 and 6. Okay, what number do they have in common? The number 2. So 2 goes into 2 one time, and 2 goes into 6, 3 times. Okay, so now we simplified. If we look at 3 and 5, the only number that they have in common is 1. And there's nothing you can do with ones. Okay? So they cannot be simplified. So now we're just going to multiply straight across. 1 times 5 gave me 5. 3 times 6. 3 times 3. Okay, be careful there. Gives me 9. Okay, here's our problem right there. Okay. So our answer becomes 5/9. And we could triple check and make sure that nothing else can go into those and that it is in its simplest form. 5, we have 1 and 5. 9, we would have 1, 9. And 3 times 3. Nothing but 1 can go into them. So we know that it's in its simplest form. Okay, looking here. Here are some more examples. Look at how they simplified within the problem. You're going diagonal across from each other. Which numbers can go into them with your factor t's? Use your factor t's. That's why we made them. That's why we spent so much time on them. Use them to help you. Okay? Let's go ahead and do D, E, and F. Pause the video. Simplify within the problem. Okay? Try your hardest to simplify in the problem instead of at the end. Welcome back. All right, so you'll see here how I simplified within my problem. Okay? Letter D, I got an answer of 1/3 because if I look across from each other here, 3 and 9, I know that 3 can go into both of them. 3 went into 3 one time, and 3 went into 9 3 times. Okay? And then anytime it's the same digit, 4 and 4, well, I know for a fact that 4 can go into both of them. So 4 goes into 4 once, 4 goes into 4 once. I rewrote my problem to make my life easier and make less mistakes. So I have 1/1 times 1/3. And I get an answer of 1/3. Okay? Letter E, I looked. I knew 5 could go into 5 once. It could go into 10 twice. Then I looked again, and I knew that 3 could go into both of them. Okay? You have your factor t's. Use them. So then I knew 3 could go into 6 twice, and 3 could go into 9 3 times. If we don't simplify this one within the problem, we end up with 45 over 60. Okay? Those are really big numbers to try and simplify. You're most likely going to make a mistake. Simplify within the problem. Save yourself that headache. Okay? And then in letter F, I knew that 5 could go into 5 once, and 5 could go into 10 twice. Nothing can go into 3 and 1. Except for 1. So we're done. we end up with 3 over 1 times 2 over 1, and we get 6 over 1. Anytime there's a whole number over 1, it's the same as just writing the whole number 6. Okay? This ends our lesson. Okay? Make sure that you come to groups with any questions. There we go. Do your extra math. Work on your bell work. Okay? Write down any questions so that when we work together in groups, I can answer those right away for you. Okay? This is the end of the video. Okay? You can go ahead and hit stop. Start working on your other things. Have a great day.